Hey there, 8th grade. Today we're talking about multiplication and division equations. Now we've already talked about addition and subtraction equations in the past, and then also again this year with all of our real numbers. And so much stays the same, but there are a few tricks that I want to point out to you. So make sure you have your name and date at the top. Get this title, and here, let's roll. Again, I'm going to show you a picture to start and try and make sense of this about what's going on with multiplication and division equations. What are we actually doing to them? So let's talk about this. What is it? Well, what do we have here? Again, we have these X boxes, hardy har har, which seem like they kind of hide a value. We don't know what the value is inside each X box, but we know that when you have 3 X boxes, then it's going to balance and be equal to -6. So again, we can convert this into an expression and say, now instead of 3 plus x, we don't have any individual tiles, but we have 3x, or 3 x's. So 3 times x, or 3 groups of x, is going to balance with -6. Now if you're thinking about scales, you're wondering what could I do to both sides? Again, that's what we're concerned with, is doing the same thing to both sides. What can I do to both sides to get these to stay balanced, but to find out what one of those x boxes is equal to? Now again, you might be just looking at it and it might seem obvious, but I want to try and think of like a theoretical way that will always work even when it's not quite this obvious. But maybe you're seeing the idea that, well, we can find out what one of these x boxes is equal to if we remove the same amount from each side. Now again, we don't know what is in those x boxes, so it's hard to know how many negatives to remove. But what we do know is that the total values are equal. And if I remove 1/3 of a total out of this total value, and I remove 1/3 of this total value, then it should stay equal. If it was equal before, it should stay equal now. And if I remove a 2/3 of the right side and a 2/3 of the left side, it should stay equal. And eventually what we're going to have here is we're going to have one individual x box, or x is equal to 2 negatives, or -2. Now what do we do there? We split it into groups. And now we saw that there was multiplication to start, but we undo multiplication with division. We split it into groups. We wanted it to cancel out. So on both sides we can divide by 3. And again, we have to do the same thing to both sides. That stays equivalent. But if you multiply by 3 and then divide by 3, those inverse operations will cancel out the 3's. We'll be left with x. And it's going to balance with -6 divided by 3. A negative divided by a positive is always still a negative. And this example maybe showed why using algebra tiles. And it's going to be equal to -2. Now you don't need to include that. And if you did, that's all right. You'll be happy for it. Your drawing will be useful in a second. But what I really want you to do is take down these notes, and they start off just the same. Equation solving notes: step 1, draw the scales of justice. Step 2, locate the variable. Step 3, isolate the variable by undoing what's been done. So the same thing still applies, but we have 2 extra notes. I need you to really pay attention to these. The first is that multiplication undoes division and vice versa. So we know that algebra tiles cancel out when we add and subtract, or when we add tiles of opposite signs. But we also know, just from that example and from our experience, that if you multiply by the same number you divided by, you undo that. If you take your age and you multiply by 2, do that for me, mentally, and then you divide by 2, you're going to get back to your age. Those 2 operations undo each other. So they undo each other. That's how we're going to solve these equations, how we're going to isolate the variable. The last note is that instead of dividing, sometimes we can multiply by the reciprocal. So sometimes if you want something to cancel out, like let's say I have 5/6 of an x, and that is equal to 1. Well, I want to find out what just one x is equal to. How do I cancel this 5/6 of an x? I could divide by 5/6, and I would have the same change flip when you divide fractions, and what you'd end up doing is multiplying by 6/5. So that's an easier shortcut way to do it. It also shows you that you're going to get these to simplify and cancel out, or they simplify rather, and we'll just be left with 1x. Now we have to multiply by 6/5. The reciprocal is just the flipped version. You don't switch the sign, you just split numerator and denominator, and we'll have x being equal to 6/5 in this case. I'm going to ask you to actually include that. So please draw that example underneath this so you know what I'm talking about when I say instead of dividing you can multiply by the reciprocal. So pause it here, take those notes, and get that example. And we're going to move on. Now again, the first example, that drawing that you had earlier is going to be useful again. So let's check it out, see what it looks like. But the problem's a little bit different. I think it's really interesting to think about what a division equation looks like if something's already being divided. So here we don't have a full x box colored in. That kind of looks like to me we don't have an x box, but we have 1/3 or an x box divided by 3. And again, that'd be the same as 1/3 because that 1 we don't have to put anything times 1 is itself. So it's kind of there already. So x divided by 1/3 is equal to -4. Now, I'm trying to figure out why does it make sense that multiplication undoes division? Well, what if I want to find out what a full x box is worth? Well, now I know I can just double what we have on the left, and we'll have 2/3. So if I double this on the left, and it was already balanced, then if I double what's on the right, it should stay balanced. And now I've almost got a full x box, but I'm going to shade in that last third, and we'll have 3/3 or 1 full x box. What is it going to be equal to? Well, again, I added another third of what was on the left, or what we started with, and so I need to add the same thing to the right side. Now what we did is we took this 1/3 and we just said, what if we didn't have 1/3 of x, but we had 3 groups of that same value? And so we did the same thing to the right. We just multiplied to undo this x that's been divided. So you can see this. If you wanted to write out some work, you might just say we can multiply the right times 3, and maybe using the little dot for multiplication would be better here. And if we multiply the right and the left both by 3, dividing by 3 and multiplying by 3, a lot of people do it up here. As long as you do one or the other, but don't do both, please. As long as you do that, we should still have it balanced on both sides. So we have just our x's left after the dividing by 3 and multiplying by 3 cancels out. -4 times 3, a negative times a positive is still a negative value, -12. So please have that drawn as well as including the notes, and pause it because we're about to move on to our other 2 examples. But again, I need you to rewind a little bit if you need to get not just the numerical representation but also the visual. Let's move on to some other examples. Number 2 is using some decimals for us, and it's saying -1600ths p, or -1600ths times p, is equal to -4 8/10. Now we'll use the same process. We're going to draw the scales of justice. Locate the variable as p. Isolate the variable by undoing what's been done, but again, if we do something to the left side, divide by -1600ths, then we need to do the same thing to the right. Okay, so these will cancel out and we'll be left with just p on the left side. And what's p going to be equal to? Well, let's figure it out. This is 4 8/10, -4 8/10. We know a negative divided by a negative will be positive, so I'll just mark that down now. 4 8/10 divided by 1600ths. Hopefully you remember to swoop. There it is. We'll swoop this decimal twice, or multiply by 100. If we multiply both parts of this fraction by 100, we'll be all good. So this is 480 divided by 16. How many times does 16 go into 48? If you know your 16's times tables, it's 3. 48, subtract, you get 0. How many times does 16 go into 0? 0. That's important because our decimal is over here. We need to fill in that placeholder 0. So p is equal to +30 in this case. Number 3, the third example says 2/5 of a number is equal to 3/10. So 2/5 of a number, how can I represent that? Well, I like to think of the word of as often indicating multiplication. So 2/5 of a number, let's use y in this case. Why not? Hardy har har. Is equal to 3/10. Now again, I want you to think about this and think about the fact that we have multiplication right here, but remember the special note we had. We can solve this by drawing the scales of justice. locating the variable as y, and undoing what's been done. How can you undo multiplication by 2/3? There's two ways. Please name them for yourself to make sure you know them. The obvious one is to undo multiplication by 2/5 would be to divide by 2/5. But to also undo multiplication, we could also multiply by the reciprocal. And that's what I'm going to do because I think that's a little bit nicer. As long as we do it to both sides, we're going to maintain equality. These will cancel out, and we're just left with y on the left side. What's y going to be equal to? Well, we can do some simplifying as we go. Divide 10 by 2, divide 10 by 5, and you get 2. Divide 5 by 5, you get 1. 3 times 1 is 3. 2 times 2 is 4. Y is equal to 3/4. Now again, if you did it using division, you could divide by 2/5, but then you would say, all right, 3/10 divided by 2/5. You'd have to change flip. 3/10 stays the same. Change it to multiply. Flip it. Instead of dividing by 2/5, you're going to multiply by 5/2. You'll get the same answer either way. It works out. This is just kind of skipping a step, showing that you know that this cancellation will just leave us with 1y. So make sure you have all that copied down, please. I want you to get full credit for this. Make sure it makes sense. If not, maybe rewatch some parts of it. And after that, I want you to move on to these example problems, which I have for you. Be sure to ask me any questions you might have, and do your best. K divided by 5 and 1/10 is equal to 1 and 1/10. Think about how you can undo what's been done. And 2 is 2/3 of h is -9. That makes no sense if I leave it as j, so find h. There we go. Best of luck. I'll see you later.